Hello, everybody, and welcome to the Reuse Company webinar. My name is Cecilia, and I will be hosting today's webinar. We have with us Elena Gallego, and she will talk about knowledge and quality management milestones in a systems engineering organization. The webinar will start in a few minutes. You will be muted during the webinar, but if you have any questions or comments, you can use the chat box. But please address your comments to the user, the reuse company, and not to the presenter. If you have any technical issues, please use the chat box or send a mail to support@reusecompany.com. The webinar will be recorded, and in a few days, we will send you the link to the recording. Okay, so let's briefly say some words about the Reuse Company. We are a worldwide company. We have partners in France, Germany, Italy, Spain, and Japan, and customers in the US, Europe, and Asia. Our headquarters is in Madrid, but we also have offices in London and in Stockholm. Here you can also see some companies that are users of our system. They are from the aerospace industry, defense, automotive, railway, and energy, among others. We provide tools and solutions for knowledge, traceability, reuse, and quality management. We do that by using semantic analysis technologies, and these technologies have been used in a wide range of industries. We haven't yet found any industry that couldn't make use of our tools. Our focus is on reuse, traceability, and quality, and we integrate the tools and technology we have with the way that you do your work. We provide the data that allow you to present your quality analysis. We allow you to develop your knowledge bases so that you can most accurately assess the quality of your specifications. Our mission is to reuse knowledge within any organization. Knowledge is probably the most valuable asset of any company, and we can offer processes, methods, tools, and services. Our technologies are innovative, AI-based, and we are having a lot of success helping people improve the quality of their documentation. We also participate in different European projects like Revamp, MS, and Crystal. Now let me introduce you to the presenter, Elena Gallego. She's a consulting director at the Reuse Company. She has experience in systems engineering in the aerospace, defense, railway, and automotive industries. The topics of interest include requirements engineering, knowledge management, software engineering, and domain architectures. She's the author of some research papers about reuse of physical system models and improvement of the quality of requirements. And she's also participating as a researcher in different European projects. Her activities are focused on helping users of our tools, the Systems Engineering Suite, to define and implement the proper processes and methods around the tools and their systems engineering approach. Okay, so let's start then with a webinar on how to manage knowledge and quality milestone in a systems engineering organization. We hope this topic will be of your interest.
Hello, everyone. Thank you very much, Cecilia, for the introduction. It's a pleasure for me to be here with you all today. I also see some familiar faces through the web cams. Some of you have enabled. It's very nice if you want to keep it, or if you want, you can also disable them as you wish. Well, for today's webinar, our goal is to highlight the main aspects that an organization applying systems engineering approaches could add in their process to manage knowledge and quality, and thus develop better assets such as requirements, models, or tests, among others. To me, there's a key element behind this idea, which is that everyone should have the possibility to access to the same information in order to optimize the quality of the assets to be developed. And how's that? Well, we'll see some examples during this session, but I'd like to start I'd like to start the webinar with an experiment. So I hope you don't mind that, but I'll show you a sentence in a minute in the screen, and I'd like you to read it. For that, I'll leave you a minute or so, and then we'll discuss about it. Please, can some of you confirm that you can listen to me or hear me? Maybe writing a message in the chat box or something, please. My colleagues from Rios company are telling me that they cannot hear me. Okay, perfect. Thank you very much. Okay, then coming back to the probably it's an issue on our side. I don't know. So coming back to the sentence that we can see now on the screen. Well, could you understand the meaning of the sentence? Because to be honest with you, if I just look at the words as they are written, it's very difficult for me to understand the meaning of descent or growth, for instance. And it's due to my background knowledge in English when I almost instantly can deduce that descent is actually does not, or growth is really word. So I'm pretty sure that if I give this text to someone who doesn't have the same English background as we have, that person could eventually understand something different, or maybe not even understand it at all. So I dare to say that something similar may happen when we write natural language requirements in our projects. And these requirements can lead to different meanings depending on the domain knowledge of the person reading it. This is something very beautiful from our way of communicating between different others, but it's also a way in which we can really be ambiguous in the things that we say. So, and I think we can even complicate this further if in our activities we compare natural language requirements with other artifacts, such as models, tests, or source code. So my conclusion from this experiment is that if we want to reduce the ambiguities and there's the possibility to introduce mistakes in our projects, we need to standardize the activities around system knowledge and quality priorities for the systems we develop at any stage in the development lifecycle. And this is what we try to tackle from the Rios company with this approach, Knowledge-Centric Systems Engineering, or KCSE. The possibility to remove any restriction to share information regardless its format and at any level in the system development lifecycle. So everyone can access to that information and thus optimize efforts and quality when developing new projects. This KCSE approach copes with this scenario by accessing to any sort of information via OSLC, which stands for Open Services for Lifecycle Collaboration, and by storing the identified knowledge in a common repository that anyone can access to, which we denominate knowledge base or ontology. Then, following this, and with the scenario that we've seen in the previous slides, let us define the goals that will drive our strategy to define the milestones in terms of knowledge and quality that we will need to overcome. Therefore, from this set of 5 goals that we have identified here, we've defined 5 main milestones that can be tackled in a practical way. So, to continue with, if we want to start from the right path, we've normally seen that a good way to do so is by discovering valuable information in the requirements documents. We've been doing or building systems for quite a long time now, and we have a lot of valuable information just stored in projects, in repositories, or we are even developing that valuable information right now, developing new projects with new technologies, with new engineers or expert ones. We have a huge variety of elements influencing our documents, and we should be able to discover that information in a pretty easy way. So this is something that, if we look more in detail into this action, if we could see that a way that we can really take advantage of that information is if we remove any possible issue or problem for our engineers to access that information, and we can provide some automatic ways to extract information from documents and possibly store that information into our repositories, either for requirements or knowledge repositories or in the ontology. The objective with this action in the end is that we can extract this information from documents from the business layer to the domain layer, representing the whole range of knowledge that we can apply when developing the system assets. So let me say that we could even perform this action in an automatic way based on either very simple configurations or more complex ones based on knowledge. So the tools can automatically identify those structures that are of relevance to us, depending on a selected configuration, which can be based on patterns or just based on simple keywords. So I'd like to show you now an example in which we'll choose a system requirements document from a Word document, and we'll store those identified requirements into an Excel file that we consider as our requirements repository in this case. So in this demonstration, we will see how we can automatically extract information from a PDF file or a Word document, as it is in the case that we see here. And then we have chosen the document that represents the system requirements of our specification in this case, which contains different elements of information, such as terms and definitions, abbreviations, tables and models, and requirements, which are the element of interest in this brief demonstration. So the idea is that we need to be able to extract this information automatically that will store the requirements in an Excel file. Then, to do so, we need to define the configuration we want to be applied for this document and how accurate we want to be the results. And we'll do two different attempts to extract the information. This first one is a more accurate one that will retrieve us very specific requirements matching with a given set of patterns that we have selected, in this case representing physical characteristics. On the other hand, we can do a simpler way of retrieving that information that might be just based on keywords, like for instance, for those requirements having a shall or a should in their requirement statement, then we can assume that it's a requirement object and we can extract that automatically. So in this case, for the example, we have identified 63 requirements. We may have seen the difference whether we can apply some configuration based on knowledge or based on complex patterns, or we can apply a simpler approach just to extract information based on keywords. Again, for this example, we've just chosen the requirement statement. However, we could perform the same sort of action for extracting any other sort of information. So, continuing in the milestones that we have to tackle, we have now discovered information in our documents. We have at least a way of of extracting all that valuable information from our documents in a more or less automatic way. And this should be the first step. Before we start, okay, now we have identified the information that we can reuse and apply to other actions. And now is the moment to control the information in order to unify the way we understand requirements in our organization. Because one of the biggest challenges that we face normally in the projects we participate is that many different users are involved in the same requirements document, for instance, and each of us have a different or sometimes even completely different way of writing requirements or understanding them. As we saw in the experiment at the beginning of this webinar, even if we have different background knowledge about the system language or the English language, we may understand different things. That's why it's very important to unify the way we want to understand and the way we want to develop our information. And this is, in our opinion, the second goal that you should overcome, which is, first of all, take all those standards that are applicable to your projects, take even internal guidelines or best practices documents that you can apply to unify and to standardize the way of developing your information among the different stakeholders, or at least among the different requirements engineers or architects that are involved within the same project. So let me show you now an example about how to organize this knowledge. And the idea is that from those standards or best practices, we might be able to extract and identify a set of vocabulary or terms, like we saw there, acronyms, to group them into different sort of libraries, depending on the typology that they are covering, for instance, for technical specifications or for statement of work, lifecycle cost documents. We organize the knowledge in that way, and then we can also develop the sentence patterns that we are going to apply for writing new requirements. And these patterns are covering the terminology and the vocabulary from our system. Another important element is to introduce also the information that we have from the system, for instance, as we are seeing now in the screen, from the different physical relationships that exist among the different system elements that we have, like for instance the product breakdown structure. So the system or the tools will be able to understand what the air conditioning system and the fan have in common. So, well, you know that the air conditioning system is composed by a fan, which is also composed by 3 fan blades in this case. So the idea is to take all this knowledge, so when a given user is going to start writing a requirement or writing a model, they can actually use this information for writing those elements. The next step then, now we have extracted the relevant information that we have in our documents. We have standardized or control the different guidelines, best practices, standards that are going to unify the way we develop our assets. The next step would be then to identify which are the strengths and challenges that we have right now in the requirements documents. It is also very important to see where are we, let's say. In the moment that you are able to see that, it will be far easier then to define the proper strategy, the proper plans and goals that you may want to overcome. So for identifying these strengths and challenges, both the good points and the things that you need to improve, we can do it by many different ways, but probably one of the most common ones is precisely to take those standards, guidelines, and best practices documents that we've seen before and apply different quality measurements on them. so we can check how do we comply according to those documents. So to do so, we have three different ways of doing quality check. The first one, and probably is the first type of quality analysis that we can perform, even without any single tool. There are some standards and guidelines also explaining some rules to cover correctness quality check. But then with this aspect, what we are going to do is to look into the requirement statements alone. We are not going to look into the whole document, but just requirement by requirement, just to ensure whether they are ambiguous, singular, they are feasible, and some other characteristics that ensure whether requirement is good or not. Once we've looked into the requirements as single elements, then we can go through the completeness quality check and look to the whole specification, so we can see how our requirements documents are, or whether our requirements documents are missing any information according to the requirements that we have already written, or are we complete in terms of the elements that we have in the ontology. Maybe we have forgotten about writing requirements for safety, for instance, and we know from our ontology that we need to have our safety requirements. This might be, or just a parenthesis, this might be a silly example, but actually we saw that once in a procurement project in a given government, in the public website of a government. So these kind of things that you forget, even safety requirements can happen from time to time, unlikely. Then we also have the consistency quality check. In this case, what we are going to do is to check whether among all the different requirements that we have in our document, there is any inconsistency between those requirements or among all those requirements, or inconsistencies in terms of the ontology. For instance, we may have defined in our architectures some specific properties for a given system, and then in the requirements we describe that property in a different way, for instance. So there might be some inconsistencies. And also in another way to look at inconsistency is based on traces, based on traceability. So we can see whether a given link between two requirements, for instance, might be consistent or not based on the content of those requirements. So let's see an example here about how to manage this quality. The first approach is firstly see the whole picture, see where we are at this time, and then in the moment that we start making progress and improving our requirements, then we can see and we can track the quality evolution for our requirements, system requirements in this case, in the example. That was the complete project of quality overview, let's say. But we can also take a look at specifically at the given requirements that we have from the correctness point of view, and then from the consistency and completeness point of view, what we can see is how does a given rule identify issues for the whole specification. So in this case, for instance, we can see how the power consumption of a given system is inconsistent if we add up all the power consumptions that we have defined in the requirements for the subsystems of that air conditioning system in this case. Because we have that knowledge from the ontology, from the architectures, and we can make comparisons. A different way to compare requirements inconsistencies is based on the similarity between elements. It is pretty common, even more if you are a company that have to exchange requirements documents with customers or with providers pretty often. So this might introduce different sort of overlapped information and overlapped requirements. Even though the requirements are written in different ways, if they are talking about the same systems, about the same information, then it's pretty easy that we end up having overlapped information that can lead to some inconsistencies. So now, let's say that we've seen the most conceptual or methodology elements, which are discovering the information from our documents, controlling that information from the standards and guidelines that we have, identifying the strengths and challenges that we have in regards to requirement quality. And now it's the moment where we can really be put hands on building up the knowledge base in this case, or ontology. And to do so, let me first introduce you to what is an ontology for us at the reuse company. And for us, an ontology is no more than a repository or a place where all the valuable information that we have from our system can be represented with different shapes and different flavors to be used afterwards and put some reasoning to perform different operations with that information. To do so, we have 5 different layers, and normally the 5th one relies on the 4th, so that's the 4th with the 3rd, and so on and so forth. So the idea is that the first step is to start with the vocabulary. So every single project, the easiest part to do is to share a common way to define things, and this should be something that everyone should almost do, even if you are not applying any of these approaches or procedures. And actually, we do that in every single document. We almost always tend to add the definitions section, abbreviations, so everyone who is reading that document can really understand what we are talking about. So the idea is to expand that list of given terms and definitions to the whole organization sometimes, or just to the given project or a given system, whatever you want to define the level of abstraction for sure. In the moment that we have this vocabulary under control, then we can start to import the different architectures or models from our system, which in the end just represent relationships between among the different elements that we have defined as terms in many cases, or just that will appear for sure in our requirement statements or in our models and source code, whatever the level we decide to tackle. The next step then would be sentence patterns. And with the patterns, what we are going to do is to define a reusable structure for writing statements or writing requirement statements that can be applied by any single user. So in this case, for instance, if we are going to represent functional requirements, non-functional requirements, or stakeholder requirements, whatever category or typology of requirements, we may define different structures that could be applied. My recommendation in general is not to have more, or to have between 5 to 10 patterns. Otherwise, it might be also very difficult to be applied by the engineers, and then you may end up by having some inconsistencies. I don't know. Well, this could be a topic just for a different webinar even. But it's the idea is just to be quite generic but specific enough, so everyone can have some guidance on how to write a given requirement, so engineers can focus on the data they have to put in the requirement, rather than thinking about how to express the idea, which sometimes can be a burden for those of us who are not native English speakers, for instance. The next step would be formalization. In this case, what we are going to do is just to define how we want the tools to understand information. So in the end, even if we are talking about a requirement or a physical model, we will formalize that information into a common language or a common representation language, so the tool can perform, or the tool, or in general, we can perform any operation on that, make comparisons, extract additional information, additional properties, or other information. And that is what we are going to define in the reasoning layer, which is the last one. In the reasoning, we are going to define the rules or tasks that will make those operations between requirements, between two requirements, or just to extract some specific information that will tell us whether a requirement is inconsistent with the rest of the specification or any other aspect. In general, you should not have to develop your own rules. Normally, it's enough with those that are in specific standards like the ISO 29148 for writing software and system requirements, or the INCOSY guide for writing requirements. Normally that's enough, and you don't have to develop further rules there. Then, once we have built up our ontology, then we can proceed and verify that the requirements that we have are really compliant with the knowledge that we have introduced in our ontology, which actually comes from our documents and from our models, and then perform quality assessments in a quicker way. Actually, something that we've seen many times in our customers is that they use this kind of verification activities or the support of these charts that we have here, or this automatic process, just to speed up the peer reviews or the verification activities that you normally have to perform in your projects. So now we have, or up to now, we've seen how the different milestones that we have, if we apply a knowledge management and quality management approach, how should be, or in our opinion, the proper step to overcome them. So we've seen that, but now really, how do we apply these milestones? And this is something that I just wanted to show you, because for me there is only one single way, which is make it simple. So every organization have different sizes, different inertia. People just work in different ways. So first thing you need to do is, okay, let's take a breath and then see whether we can do some sort of a step-by-step procedure so we don't spend too much efforts on doing this. It has to be something simple, something that you can really manage and handle. So, for instance, if we were to say some best practices on how to do this, this slide is just representing some efforts, statistics that we've seen from different projects in which we have applied these milestones, and we have done that in a continuous improvement process approach, let's say, which means that we have defined different, what we call belts, quality belts, like a white belt, a yellow belt, orange, and so on until the black belt, which is the master ones for quality and knowledge management. The idea is to do it in an incremental way, so for sure, in the moment that you start, you will have to apply more efforts because you have to start moving all this approach. But then in the following stage would be easier and require less efforts, and so on and so forth, until the efforts are almost known, because it's just a matter of maintaining the information that you have there. There are different ways to evolve, but for sure you should always be able to complement either quality management and knowledge management, which means that you need to evolve your ontology at the same pace that you are evolving in terms of quality. Then, practically speaking, what this means is that for all the specific activities that you have to overcome to succeed in those 5 milestones that we've seen so far, the idea is that just you can group them together to make different belts, let's say, that will just have specific goals until you can really handle the complete process. Also, from a different point of view, how does really these milestones or this KCSE process enhance your current activities? Well, what we've seen so far is that it may imply a 40% cost saving from the systems engineering cost that you may apply in your projects. And the way we have seen that, or the way we have measured that, is based on a COSYSMO model, or Constructive Systems Engineering model, which just computes the efforts and cost that a given system may imply in relation to the systems engineering cost that we have. And this is a model that was developed by the MIT, and they have tested it with several requirement specifications from a group of customers of them, or just collaborators of them, and they have just identified elements that are relevant to measure those as system requirements, system interfaces, the number of system requirements, number of system interfaces, or number of functions and operational scenarios that we have in a system, just to extract some cost drivers to measure really the impact that they have in the cost analysis. And it happened to be that requirements understanding was the cost driver that most impact has in the cost analysis, or in this model. So we took advantage of that just to measure, okay, let's try to measure how can we improve the understanding of requirements and the understanding of architectures in our system. And for a given project, in this case, for instance, we have taken an example for around 200 system requirements that has around 50 system interfaces with about 500 different functions and working in 100 different operational scenarios. And what we've done is just, with all the different parameters that they have, by the way, I haven't said that, but if you look for COSYSMO on the internet, you can access to this tool and you can do the analysis for your own projects. So you just Google it and you will probably find it pretty easily. So what we've done is just to play a little bit with the requirements understanding. So we went from nominal, which is just, okay, we have a regular understanding of our information. There are some requirements that we don't really understand well, that can be ambiguous. There are some others that we really understand very well, that are easy to understand. Okay, having an estimation that of a cost per person month of about $6,000, it happened to be that the systems engineering cost for these nominal values, it's around $9.5 million. If we move the parameter for the requirements understanding to high and the architectures understanding to high, which means that, okay, most of our requirements are easy to understand, are not ambiguous. There are still some of them that we don't really understand, but, well, mostly we understand all of them. Then we see now a cost of $5.6 million. If we just go to the very impressive, very high, which means that, okay, we understand almost every single requirement that we have, though we still have some very complex requirements or difficult to understand requirements, but then we would go down to $3.5 million or something like that. So it means that in the end, just by incrementing our understanding of requirements and architectures, by applying, for instance, approaches such as the KCSE approach, we can have a cost savings of almost 40% cost saving with our percent change from nominal to high is 37, almost 40% of cost saving, which if we compare that with the cost of applying, for instance, the technology, the approach, it means that a user for something similar to the scenario we've seen could have the return on investment in about 16 months. So let me then highlight three main conclusions or three main ideas that I'd like you to take away, which are: we may have different approaches to enhance projects in my opinion, in the same way that we spend sometimes huge resources or quite a big budget for managing requirements. Why don't we start from the very beginning and work also on developing the proper information, developing good requirements, not only managing them, but also to ensure that that information that we are managing, that we are storing, that we are tracking is really good information, is not just information. Because this can really save us some money. So a way of doing that, and this would be the second conclusion, is that we may rely on our knowledge, on taking advantage of the information that we have in and commonalize or standardize that information in ontologies, for instance, by using the proper tools as well, or using the proper frameworks. And in the end, and this is for me one of my favorites, everything or any process, tool, whatever, you need to tailor that to fit into your own processes. I don't think, or at least I don't see there is the perfect tool that will fit in your organization process. Rather than, I prefer to think that you need to tailor that framework, to tailor the combination of processes, tools, and people in order to really optimize it for your own organization, so you don't spend too much resources on that. So thank you very much for listening, and I'd be very happy to hear your questions now.
Thank you, Elena. If anyone has comments or questions, you can send them through the chat box to the reuse company. Let's see. Yes, we have one question. What is your recommendation to start applying this approach? Should we start with a new project, or can we apply it to ongoing ones?
Well, that's a good question. I'd say there is no the perfect answer to it. It will depend very much. It will depend because I think you can extract different information from one situation, or you can extract different results from one situation and the other. For instance, if you start applying this technology by reusing information from previous projects, you will be able to identify or to explicit a lot of knowledge that you already have spread into different documents. The problem is that you can end up having too much information to handle, and that's something that you also have to be careful. On the other hand, so it is good, or the advantages of starting with an existing project is that you will have a lot of information that you can reuse. The counterpart is that probably you will have to spend more resources, time, and money to really get to good results. On the other hand, if you start directly with new projects, you may have a lack of information from previous projects that you may have done. So if I were to say how to start, then I would say make a use case. and combine both. Take advantage of having a new project, for instance, but be aware of that information that you have already developed. So you can use also part of that information as inputs for your new projects. Because I don't know, it may not happen to you, but for me, I think the most difficult part normally, even when you start with a document, is the white sheet of paper and just to write the first sentence, let's say. So if you can reuse something from the past, that would be very useful. However, try to make a combination, not to go to just one extreme or the other, but try to take advantage of both situations. I don't know if this may answer your question. I hope so.
Okay, thank you. Another question. How much could it cost us to get an orange belt as you presented? It would be in terms of licensing and the training.
Well, this is really a good question, and if the previous one depend on the scenario and the organization, this probably depends even more, because it will depend on how much, or well, first, which are your goals, and where do you want to get. For instance, in the scenario that we see here in this slide, I remember for this project we had around 400 requirements. There were around 4 people involved from the company working on this project, and we spent something like 3 months working on it. So, and the results were just to design and implement the orange belt, as you were asking. This is where we got. So in this case, what we developed was a proof of concept, which is the customer don't have to go straight and buying the tools. Actually, I don't really recommend that. I think that when you decide to go for this technology, you have to be sure that it will fit with your processes in your organization. So my personal recommendation is first to start with an evaluation in a use case, or having a use case where you can really make an assessment on the results and see whether it really helps you or not. So this is what we did here. This was a proof of concept. In it, as I mentioned before, we had a small set of requirements, around 350 requirements, and we just worked on that. We worked on on measuring the efforts, the time, and the cost that it will have. These proof of concepts that we offer, there are different sizes, different scopes, and they go from 4,000 euro to 20,000 euro, depending on the goals. For the orange belt, normally is the 20,000 euro POC. So this could be more or less the cost. For sure, it will depend in terms of, it includes training, consulting, the licenses for 6 months or something like that. So in the end, this could be an approach. But I think if you like, probably you can email us and we can provide you a more accurate answer for your situation, and maybe that's useful for you. Okay. I hope that answered more or less your question.
Okay, thank you. No other questions. So thank you very much to all the participants, and thank you very much, Elena, for your presentation. If you have any further questions, or if you want to have more information, don't hesitate to contact us by email to contact@reusecompany.com or by our website, reusecompany.com. Next month, we will have another webinar. It's called How to Write Requirements in the Space Industry Using a Knowledge Library Based on ECSS standards. This is about the European Cooperation for Space Standardization. It's an initiative established to develop a set of standards aiming to gain a common understanding across the space industry in Europe. ECSS has released some guidelines for the development of technical requirements specifications, and the reuse company has developed a knowledge library coping with the ECSS standard to guide requirements writers writing high-quality requirements and provide help during the long-lasting requirements inspections, thus making easier the compliance with the ECSS standards. This knowledge library is part of the Systems Engineering Suite managed by our tool Knowledge Library, and include glossaries, taxonomies of terms, taxonomies of types of requirements, requirements patterns, and requirements quality rules. The dates for these webinars are Tuesday, November the 20th at 5 p.m. and Wednesday, November the 21st at 9 a.m. Thank you very much for your attention, and hope to see you on our next webinar.
Thank you very much. Bye-bye.